Okay, next we are going to be talking about 3.5, which is the derivatives of trigonometric functions. So let's see, we have sine, we have cosine. The derivative of sine is cosine, whereas the derivative of cosine is negative sine. These formulas can be obtained again by using the limit definition of the derivative, which we are not going to do it right now. You guys know the graph of cosine, right? What's there on top? The blue one is the cosine function, and then here's the derivative of it. How do we get to that? We just look at this horizontal tangent lines. At 0 there is a horizontal tangent line, at pi and negative pi we have the horizontal tangent line. That would mean the derivative is going to be 0 on these points, like 0, pi, negative pi, 2 pi, negative 3 pi, etc. The derivatives are all going to be 0, so let's plot them here. At 0, 0, at pi it is 0, at negative pi it's 0. Then we are going to just combine in between, but we have to be careful here, because between 0 and pi, look at the tangent line. Tangent line has a negative slope, right? Therefore, between 0 and pi, we cannot draw it like this. We have to draw under the curve, okay? Because the slope is negative. That would mean that the derivative is going to take negative value, so we have to go down here. And then after pi, if you look at after pi, if you draw a tangent line here, it's a positive tangent line, so the function takes, the derivative is positive there, so therefore it has to be above the x-axis, okay? That's how we draw it. Similarly, between negative pi and 0, negative pi and 0. Let's look at that, negative pi and 0. Look at the tangent lines. The tangent lines are all positive, right? They have the positive slope here. So therefore, between negative pi and 0, the derivative has to be positive, which means above the x-axis, okay? That's how you would draw the graph. So by just looking at this and by just looking at the horizontal tangent lines and plot them first in here, where they are just 0 here, and then in between just look at the tangent slope of the tangent lines. If positive, draw a curve above the x-axis. If the tangent line has a negative slope, draw a curve below the x-axis, okay? That's how you would do that. Alright, so let's see. You can consider a vertical spring. This is a vertical spring. This is at the no movement position, and then here there's a the spring is hanging, okay? The weight is going to cause it to go down a little and a little bit down, okay? Actually, at 0 it is the rest position, it says. Let's see, just a sec. There's an oscillation. This spring is going to oscillate, okay? So it's gonna go down and up, and this is the rest position. This is where it's gonna rest at the end till it gets the steady motion, okay? So this is where it starts actually. So this is where it starts. This is the rest position, and then the weight is going to take it down, but since it's a spring, it's going to go up to -5 and come back to -5, -5, in between, and then till of course we will we can just touch it, or the weight is going to cause it to go down and up, and then at the end it's going to rest at its position 0, okay? S is equal to 0. So these are the actually the previous one is also example 3, I believe, right? Yeah. This is the vertical spring, okay? A weight just hangs and it's gonna go up and down. So it's a periodic motion that is going up and down. So therefore we expect that its position function is going to be represented by either cosine or sine, because it's periodic, right? It goes between -5 and 5. So at the initial position, okay, it's let's say time t is equal to 0. We are gonna take, so it's gonna be 5, and then it's pi over 2, time t is equal to pi over 2. It's gonna be at the rest position at pi, it's gonna be at -5 position, and then 3 pi over 2, it's gonna come back to rest position, and then at 5 position, and it's gonna go down, up and down, up and up, up and down, up and down. Actually, if it's an ideal situation, it's gonna be continuously going up and down, up and down. But of course, there's other things that's gonna cause it to stop. For example, air is going to cause it slow down. Okay, gravity, we have gravity as well. Okay, some other forces, it's gonna make it slow down in real life. And what's the velocity? If you consider the velocity, if you take the derivative of this, you get -5 sine t. At time t is equal to 0, the velocity is 0, and then because of the weight, right, the velocity is in the opposite direction with 5 at pi over 2. At time t is, okay, when it's at rest, the velocity is in the opposite direction with 5, and when at time t is equal to pi, it is going to be okay, the velocity is going to be 0, it's going to stop, and then increase, the velocity is going to increase, and then the velocity is going to go slow down, and it's going to be 0 at rest. Okay, so it's going to be like that. Let's see, just a sec. I want to make sure. Let's see. When it's 0, which is pi over 2, 3 pi over 2. 3 pi over 2, speed is 5. Still it has the velocity, so that it can continue moving up and down, right? Okay. How about the derivatives of other trigonometric functions? For example, tangent, the derivative is going to be secant squared x. How would you find it? You look at sine x over cosine x. You use the quotient rule for the derivatives, and you're going to get secant squared x. Or you can memorize it, okay? The derivative of secant x is secant x tangent x. Again, secant x is 1 over cosine. You can use the quotient rule for derivatives, and you can get secant x tangent x. The derivative of cotangent x is cosine over sine. Use the quotient rule for derivatives, apply it, and you're going to get negative cosecant squared x. Just one sec. Okay, so as you would see, let me go back to the page again, sorry. The derivative of secant x, as we said, 1 over cosine x, use the quotient rule and take the derivative. And cosecant x, 1 over, sine x, and you use the quotient rule and you get that. Alright, so let's see what is next. This is chain rule, right? I'm going to do the chain rule in a different recording. Okay, I'm going to stop this now.